So we start this year with linear functions, and linear functions are something you know, and you know actually really well. I'd say you've been working on linear functions for sure since 6th grade, every year, probably even laying the groundwork, really for sure laying the groundwork before that. So when I say y equals mx plus b, I should see everyone nodding their heads like, yes, y does equal mx plus b, where the m and the b are constants, and we'll talk about them one at a time. What does the m stand for? You are right, the m is the slope. What is slope? Well, slope is first introduced to us as like a slant, right? As the slant of the line. Or more specifically, the rise over the run. Or you might even see this, change in, the triangle means change, delta y, change in y over change in x. How far it goes up, down versus how far it goes left, right. In pre-calc next year especially, they're going to use the words rate of change for slope. Slope is a rate of change. We have different lines with different slopes, right? If we go up the hill, we have a positive slope, and that's because we had a positive rise and a positive run, and a positive over a positive is positive. If we go down the hill, we have a negative slope because we had maybe a positive rise but a negative run. Or you could do it this way and say you had a negative rise and a positive run. Either way, a positive over a negative or a negative over a positive is always negative. So up the hill is positive, down the hill is negative. What about a horizontal line? Oh, I already wrote it. Horizontal line has a 0 slope. Why? Is there a rise between these 2 points? Does I go up or down at all? No, I just have a run. And the run might be positive or the run might be negative, but anytime I have 0 in the numerator of a fraction, do you agree that it's 0? Yes, so I always remember horizontal has a z in it, and it goes with 0, or sometimes we say you can make a z with a horizontal line. Horizontal line has a slope of 0. Our last one is our vertical line, which is an undefined slope, also known as no slope, also known as empty set, right? So undefined slopes or vertical lines have a rise, which could be positive or could be negative, up or down, but what about a run? Don't have it. What happens when you have 0 in the denominator? Can't do it. So empty set, or what we say is undefined slope. And sometimes I say like a U for undefined can be made out of a vertical line, or even an N for no slope can be made out of a vertical line. Do you remember the formula for finding slope? I'll add that up here. Right, y2 minus y1 over x2 minus x1. Or 5 minus 0 over negative 2 minus negative 4. Does it matter what order you subtract? It does not, but you have to be consistent, right? 5 over, this is going to be 2. Yes, 5 over 2. 4 minus 4 over negative 2 minus 3. You cannot leave an answer like that. That is not reduced. You need to reduce it to, yes, 0. 5 minus 3 over negative 4 minus 2. Same thing here. You cannot leave an answer like that. You have to reduce it. By the way, with a negative slope, it doesn't matter if it's negative in the top, the middle, or the bottom. It's still negative. And then, just to be fair, we have our final one with a 0 in the numerator, which we also cannot leave like that. We need to reduce to empty set. So we had a positive, a negative, a 0, and an empty set. Slope. Before I get into intercepts, I'm going to talk a little bit more about horizontal and vertical lines, just making sure we know the difference. Horizontal line is like the horizon. We already said that it had a slope of 0. Do you know what an equation of a horizontal line looks like? Right, it's a y equals equation, like y equals 4 is the equation of a horizontal line, because every point on a horizontal line has the same y coordinate. Similarly, with a vertical line, which has no slope or undefined slope, this equation is x equals. These are just examples. It's not saying every horizontal line is that, but just as an example, every x coordinate on every vertical line is the same. So we have a nonsense word, havex, that helps us remember that a horizontal line is y equals, and a vertical line is x equals. It's easy to confuse, so havex helps us remember. Okay, now we can get into intercepts. The y-intercept, I guess we did first. Now, y-intercept is a little bit more famous, so it gets its own letter. The y-intercept is the b, and y equals mx plus b. And this is the point, ordered pair, where the graph does what? Crosses the y-axis. The y-intercept is where the graph crosses the y-axis. The x-intercept doesn't get its own letter, but it's still where the graph crosses the x-axis. And there's some things that are always true about the x and y-intercept. The y-intercept always has an x-coordinate of 0, and the x-intercept always has a y coordinate of 0. And that's how we can find them. So sometimes I call this the 0 thing, where like I put in a 0 for x, and then I put in a 0 for y. If I put in a 0 for x, 2 times 0 plus 3 times y equals 6. Isn't y just 2? So that ordered pair 0, 2 is the y-intercept. Change colors here. If I let y be 0, 2x plus 3 times 0 equals 6, I get 2x is 6, so x is 3, and 3, 0 is the x-intercept. And then I can connect them to draw my line. Lines have infinite number of points. 2 of those points are the x-intercept and the y-intercept. If I do the same thing here, if I put in a 0 for x, does 0 equal 4? No. So there is no y-intercept. If I plug in y equals 0, there's no y to plug in, saying that the x is always 4, 4, 0. 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. The x is always 0. So most vertical lines do not have y-intercepts. Not every single one, because I could have a vertical line, right, that has an infinite number of y-intercepts. But unless it's that line, then the vertical lines don't have y-intercepts. Similarly, the horizontal lines here are not going to have x-intercepts, right? I can't let y be 0 because y is always 2, but I can let x be 0 and get a y coordinate of 2. So again, a horizontal line, this has no x-intercept, where this one had no y-intercept. So kind of our special cases of x and y-intercept. I gotta flip and see. Yep, that's tomorrow. I'll just stop right there. So yep, so here we have slopes and intercepts.